Very good morning to all of you. We are here to learn the subject Advanced Construction Technology. We are talking about unit number 1, Modern Materials and Equipment used in the special construction. In the previous lecture, we have discussed effect of the lateral forces. We have discussed wind effect. We have discussed water effect, that is your hydrostatic pressure. In this lecture, we are going to discuss the earthquake load effect. So let us start. So these things you have already discussed. Basic behavior. Due to the gravity, the building collapses in the vertical plane. While in case of lateral loading, it will create a sway effect. Okay. These things, all of the things we have seen. Okay, just go through it so you will get the basic idea. And these all things you have already learned in the previous lectures. Okay, wind turbulence, then hydrostatic pressure, similarly buckling of the column or basement wall, water pocket. Here you can see the capillary action, water effect video, methods for the waterproofing of the basement. And yes, we are going to discuss earthquake forces or earthquake load in this lecture. But before that, if you have still any kind of doubt in this lecture or previous lecture, you can directly contact me. Why sir is posting a video from YouTube to explain us? So then I can also explain you why I am posting the video in between my video lecture. So if you have any kind of query, if you have any kind of doubt, and if you have any kind of problem, you can directly contact me. So now let us discuss earthquake force. So this figure basically give you a brief idea about the earthquake load. Here this is your building, this is your ground level, and finally this is your epicenter. So what is written here? Ground shaking during an earthquake. Many reflections in the refraction occur along the path, and filtering for the frequency occurs especially under the building. So that means the wave will move like this. This is a typical figure, so you will get the idea. Then we have a epicenter, okay, which create an impact on the ground, and finally the waves travel towards our building. Okay, so that is the basic fundamental of the earthquake forces. And this figure also give you a basic idea. So maximum force at the bottom. Here you can see at the ground level. Now if we compare the wind effect and the earthquake load, here you can see the wind is uniformly distributed to our surface area, okay, of a particular building. While in case of the earthquake load, here you can see it is not the uniformly distributed, it is a UVL load, uniformly varying load. So you can see the maximum force that will occur at the top of the building. The maximum thrust you will get at the top of the building. Why? Because the ground is shaking very heavily. So that will create a thrust on the top of the building. So this is the comparison of the wind load and the earthquake loads. Now this will also give an idea. Here you can see we have seen the three-dimensional image of the particular building having a multi-story building. So dotted line will indicate the original position. If the earthquake occurs having a certain kind of the magnitude, the building will move like this. Definitely you cannot see the movement like this in the existing in the real world. It is a relatively small effect. So if you put a sensor over here at this 4 at the bottom, 4 sensors at the top, and 4 sensors at the midway, so you will get the idea regarding how my building is moving during the earthquake. Okay, so that kind of experiments are already we are doing in our laboratories. Next is earthquake loads. So difference in the design effect of a building during a natural action. A for the earthquake ground movement at the base, and B for the wind pressure on the exposed area. So here you can see the different kind of the movement are there. You can see the deflection at the roof, and this will create a sway movement during the earthquake. Ag is your acceleration and T is your time. Okay. Similarly, earthquake resistance design philosophy for the building. Here you can see A this figure A will showing that a minor or frequent shaking, no hardly any damage. This is indicating a very low amplitude earthquake. B, moderate shaking and minor structural damage and some non-structural damage. Earthquake scale is low as compared to the C figure, so that will create a minor effect. Okay, that will create a moderate effect on our building. And finally, building C, a severe damage or infrequent shaking, it will lead to the structural damage but no collapse. Because of all of these three buildings will not collapse in the gravitational direction, because we have designed these buildings as a earthquake resistance building. You won't find the earthquake proof building because there is no building which is earthquake proof. We have a earthquake resistance building. So this philosophy you need to understand. Similarly, here you can see what is there. A building is there, earthquake resistance but not earthquake proof. That what I mentioned in the earlier slide. So damage is expected during an earthquake in the normal construction, undamaged building and damaged building. This is your undamaged building and this is your damaged building. So in brief, what you are going to do actually in the field, while in case of the designing a earthquake resistance building, you need to check out basic three parameters of any particular building. First and foremost thing, you need to take care about the behavior. Second is analysis, and third one is design. So here you can see the design is directly connected to the behavior. Similarly, analysis is also directly connected to the behavior of the building, and design and analysis both are interconnected for a particular building. So if you want to design an earthquake resistance building, check out the behavior first, then go for the analysis. After checking the behavior and analysis, you will go for the design and actual implementation of a particular building. So this is for the earthquake load, this is for the earthquake resistance building design construction. Are your references for these lectures, so you can check it out directly on the net. And thank you very much and have a nice day.